Hanson is part of Heidelberg Materials. In 1873, Johann Philipp Schaufeldecker started producing Portland cement, then a completely new building material, with just 35 employees in Heidelberg, Germany. He probably never imagined that 150 years later, Heidelberg Materials would be one of the world's largest manufacturers of building materials, with around 51,000 employees at almost 3,000 locations, 50 countries across 5 continents. Heidelberg Materials is a global leader in aggregates and has leading positions in cement, concrete and heavy building products. In terms of Hanson, Hanson is a leader also in building construction materials within Australia, has an extensive production and logistic network across the country. Hanson Australia supplies a comprehensive range of high-quality concrete, aggregates and sand, as well as road base, asphalt and sustainable and recycled construction materials. Hanson Australia also holds a 50% stake in Cement Australia, which is the largest cement company in the country. And interestingly, for those that have been around for a little while, the foundation of the Hanson Australia business is Pioneer International, which commenced in St Peters, Sydney in 1954 and grew to become a multinational construction materials business that was acquired by Hanson in 1999. Some of you may remember the green trucks that used to travel the roads back then. The following video provides further insight into what Hanson does. It was interesting that I was sitting here just before and it was mentioned about the distraction that can be caused by these windows, and I was looking across the waterway to a piling job across the way, and I could see a Hanson truck delivering concrete to that construction project right across there. On the next few slides, I'm going to highlight the significance of the quarry and broader construction materials industry to the Australian economy and its contribution to society. Sorry, I'm pressing the wrong one. Okay, so the quarry industry, it's vital to the nation's $200 billion building and construction industries. I won't go through all these numbers, but I'll just highlight that every Australian requires 8 tonnes of stone, sand and gravel every year to build the roads, houses and other infrastructure we need. To build the average house, we use around 110 tonnes of construction aggregates and 53 cubic metres of concrete. To build 1 kilometre of 2-lane highway requires about 14,000 tonnes or 400 truckloads of construction material. So what does all this mean? If you want airports, train stations, schools, hospitals, public buildings, houses, roads, bridges, or essentially the built environment, we're going to need cement plants, concrete plants, hard rock quarries, sand quarries, asphalt plants, and recycling plants. So let's take a look a bit more at the future. As we look into the future, the quarrying industry is poised for significant transformation driven by technological advancements and a growing focus on sustainability. But when I reflect on the trends we see now and how these might evolve and impact the quarrying industry in the future, I think of 3 key areas which also overlap and in many respects are interrelated. The first one there is people. It underpins everything. Sustainability, it's needed for a long-term future. And then technology and innovation, it's going to help us get there on that path. So I'll focus on each of these going forward. So the first one is people. So as I mentioned, it underpins everything we do, and we won't have much of a future if we don't get that right. So how do we retain and attract the talented people required for industry? It's a competition for talent, as we all know, and we can't rely on traditional avenues to find this talent, which has generally been men with experience. Employee diversity will be extremely important in attracting the talent we need, and as an industry, we can see progress in this area is being achieved. In terms of training, the future of quarrying is intrinsically linked and connected to a workforce development. As automation and advanced technologies become more prevalent, the industry will need to adapt and equip its workforce with the necessary skills. Quarrying companies must invest in training programs and encourage lifelong learning to facilitate a smooth transition into the future. Health and safety performance will continue to be a massive focus for the quarrying industry, as it should be. And when I think about our business, the highest risk area for loss of life or a serious incident is when our drivers are on public roads and interacting with the general public as they deliver our materials. This is why, as a business, we've embraced autonomous safety technology in our truck fleet, and this includes the rollout of the Guardian driver fatigue and accident prevention solution to over 650 vehicles within Australia, including our yellow fleet within our quarry sites. Continual improvement design and new plant and equipment will also improve safety outcomes. Similar to most aspects of our business, and as I mentioned, there's a lot of interrelation between those three key themes. Technology is going to play a vital role in improving safety outcomes. The second theme that I was going to focus on is sustainability. So the future of quarrying encompasses sustainability and environmental stewardship. As we strive to build a more sustainable future, the quarrying industry will need to address its environmental footprint. The industry will face questions regarding land use, community engagement, and the preservation of natural habitats. Striking a balance between responsible extraction and the preservation of our environment will be a critical task for our industry. Collaboration across industries, environmentalists, local communities, regulatory bodies, it's going to be essential to ensure sustainable practices and the preservation of biodiversity. In terms of the broader construction materials industry globally, the most significant area in terms of carbon emissions is cement manufacturing. And it is this area that's getting the most attention internationally. When limestone is heated and converted to clinker, CO2 is released. It's a fundamental part of the chemical reaction and it can't be prevented. Clinker is the raw material used to grind and manufacture cement. Heidelberg Materials has implemented a number of carbon capture, utilisation and storage initiatives at cement plants around the world. Another key focus for the industry is energy efficiency. Quarry operations will adopt cleaner, more energy efficient processes, reducing carbon emissions and the reliance on fossil fuels. Renewable energy sources such as solar and wind will be powering our operations, further reducing the industry's environmental impact. And finally, the quarry industry will witness a transition towards circular economy principles. Instead of simply extracting raw materials and discarding waste, quarrying operations become more resource efficient and waste conscious. Techniques like on-site recycling and repurposing of waste materials will minimise the need for extraction and reduce the overall environmental impact. I can't emphasise enough sustainability and its role for the future of my industry. It's a massive focus for the business, and I thought I'd touch just very briefly on Heidelberg Materials' sustainability commitments. The world needs smart, sustainable and resilient infrastructure. Buildings and public spaces Challenges like climate change and resource limitation mean the production and use of heavy building materials must evolve. At Heidelberg Materials, we are transforming our business to address these challenges and placing sustainability at the core of what we do. The United Nations Sustainability Development Goals shape our strategy and sustainability commitments. Our sustainability commitments for 2030 support our vision to build this future. And as it sort of highlights on that slide, number 1 is net zero. Safe and inclusive is number 2, 3, nature positive, and 4, circular and resilient. There's more detail on this slide, which I won't go through in detail, but I just wanted to highlight a couple of the specific commitments that's under each of those 4 headings or 4 categories which I just mentioned. So under the building a net zero future, the commitment from Heidelberg globally is that we will capture 10 million tonnes of CO2 cumulatively through our CCUS projects and achieve 50% of our revenue from sustainable products that are either low carbon or circular. Another one I'll just highlight is just on the category building a circular and resilient future. So offer circular alternatives for 50% of our concrete products, aiming for full coverage. As I mentioned, when I think about this, and more than anything else I've said today in terms of giving you an insight into the transformative forces within the industry, is Heidelberg Materials sustainability strategy commitments. And just lastly on this topic, I mentioned cement manufacturing. The key challenge for the industry is carbon capture. That's a picture of Heidelberg Materials cement plant in Norway, which is one of the sites undergoing one of these initiatives. And as Heidelberg Materials Chairman of the Managing Board, Dr. Dominic von Achten, has said, carbon capture utilisation and storage continues to be a key part of our climate strategy. With now 8 large-scale initiatives worldwide, our CCUS project portfolio keeps growing and is scaling up fast. Our ongoing projects in Europe and Canada are progressing well. In Mitchell, in the US, we will build on this experience of those projects to supply carbon-free cement to our customers in the important US market at large scale.
Good morning, Bob.
Hey, Aura.
Here's your morning coffee. Triple shot again?
Stronger the better, Aura. What do we have on the books for today, Aura?
246,350 tonnes for the day, Bob.
Quiet day. That'll be nice for a change. Can you show me the operational update, please, Aura?
Here is the operational update for today. Systems coming online. There is a delay at the crushing station. I do not expect any delay in start time. Plant launch starts at 0630 hours.
All right, let's have a look then.
Site launch starts in 3, 2, 1. Site launched. Currently dispatching drones for plant and quarry monitoring. Drones are now en route to the plant sector. Drone D25 has scanned and sourced the issue within the crushing quadrant. Drone D64 is now entering the crushing quadrant for machinery scan. Oil pressure issue has been located. One of the oil line connections has a leak. Scheduling Android bots for immediate service. Continuing operational scan of the plant, Bob. Receiving visual of crusher lubrication units from drone D25. All crusher lubrication units are in working order. Here's a fresh coffee, Bob.
Thanks, Aura. You're reading my mind.
Happy to help your coffee addiction, Bob. It's not like you have much else to do. Bob, drone D55 has picked up a low oil level on the gearbox of conveyor 5. Scheduling oil order and top-up service by Android bots.
Great, Aura. Will the gearbox perform without damage until the service?
Yes, Bob, the gearbox won't sustain any damage prior to the service.
Okay.
Bob, we have a high temp alarm on the idle side head drum bearing. It is currently at 82 degrees, predicted bearing failure in 23 hours. Fault is being linked to maintenance for request of roller bearing repair. Parts ordered. Scheduling repair time.
When was that bearing last changed out?
The bearing was last changed out on the 25th of May 2063 and has been serviced exactly to schedule by drone D37 for the period of its life cycle.
Does the length of the service fall within the predicted life cycle?
Yes, it fits within predicted parameters, Bob.
Great.
Quality analysis underway. I've provided you with the results along with the grading curve.
Thanks, Aura. Perfect as usual. Send those off to the concrete batch computer.
Quality analysis have been sent off to the concrete batch computer. Mix designs have been updated, Bob. Tippers have now entered the plant for loading. Travel location has been updated and remaining tipper fleet information supplied. The tipper fleet is now entering the loading facility. Incoming call from our customer Susan.
Put her through, Aura.
Okay, Bob.
Hello, Bob speaking.
Hi Bob, how are you?
Good, Sue. What can I do for you?
Bob, we had a lot of rain last night on site. Are we able to reduce the moisture content on that 2.1 by about 2%?
Yeah, not a problem. I'll get that process for you now.
Oh, thanks Bob. Have a good day.
You too. Aura, drop the moisture content in Sue's order for today to 3.5% and update her allocated trucks.
Okay, Bob. Order updated. Changes sent to allocated tippers.
Okay, great. Let's have a look at the load and haul fleet out in the quarry.
Sending drone D55 to quarry for visual.
Or give me a visual rundown of the machinery status. Let's make sure everything here is performing at optimum before moving on.
Copy that, Bob. Providing visual status of haul truck HT713. Drone D55 providing visual status of loader ML03. Everything seems to be in check, Bob. Machinery is working at optimal performance. Moving on to perform an environmental scan for pit wall stability and airborne contaminants. Drone pit stability scan in progress. Pit stability scan complete. There are no signs of instability, Bob.
Great. Let's schedule another scan for next week.
Scan has been scheduled.
Thanks for your help, Aura.
Anytime, Bob.
While you might think that I put that together for this presentation, I can't take any credit for that at all. It's a colleague of mine put that together for an internal conference we had with our quarry managers, just to try and inspire them and think about the future. But I thought it was quite relevant for my talk today. So while this video was quite futuristic, you can see a few trends today that will likely lead in that direction. Not so sure about the end in getting to the moon, but certainly a few things that are happening today that you could see that, you know, that is a potential for some time in the future. So just going on to the third theme, and that video was certainly part of the technology and innovation category, which I sort of mentioned up front. But the future of quarry industry is expected to involve advancements in technology and processes to improve safety, efficiency and sustainability. Like most, probably like most industries, the quarry industry is no different. Mechanical engineering will play a crucial role in driving these advancements and addressing the challenges faced by the industry. And here are some potential developments, and based on the audience, I thought I would highlight the role of mechanical engineering in each of them. So the first one there is automation and robotics. Quarry operations are likely to incorporate increasing levels of automation and robotics, and mechanical engineers will be responsible for designing and developing autonomous vehicles, robotic systems, automated material handling equipment. And these advancements will enhance productivity, reduce human error, and improve safety. At Hanson, we've developed our own in-house capability in terms of automation and PLC systems. As part of Hanson's Quarry Automation Standardisation Initiative, we are progressively upgrading old, obsolete PLC systems with newer I/O hardware and rolling out copper data Xenon. Remote monitoring and control. Mechanical engineers can contribute to development of advanced monitoring systems using sensors, data analytics, AI. These systems will enable real-time monitoring of equipment, performance, environmental conditions, worker safety. Remote control and diagnostics will allow engineers to optimise operations, detect faults, and schedule maintenance proactively. And again, going back to sort of the interrelated aspect of those three key things that I mentioned, sustainable practices. As I've already highlighted, the industry will continue to focus on sustainability by minimising its environmental impact. Mechanical engineers will work on designing energy efficiency machinery, reducing emissions from equipment, developing innovative technologies for water management, waste disposal and land rehabilitation, explore ways to incorporate renewable energy sources and optimise resource utilisation. Material handling and processing. Mechanical engineers contribute to design and improvement of equipment for material handling, which is a big part of our business, crushing, screening and sorting processes. They'll aim to increase efficiency, reduce downtime, minimise the generation of dust and noise. Optimisation of conveyor systems and development of advanced separation techniques will also fall under their purview. In terms of safety, it's a critical concern in quarry operations, and again, mechanical engineers can contribute through the development and implementing safety systems and protocols such as machine guarding, proximity detection, automated emergency response systems. Also focusing on designing ergonomically sound equipment and workspaces to reduce the risk of accidents and injuries. And lastly there, 3D modelling and simulation. So mechanical engineers will utilise 3D modelling and simulation techniques to design and optimise the way we lay out our quarries, equipment configurations and operational processes. Even the possibility of virtual reality and augmented reality technologies can be employed for training, planning and remote collaboration, with allowing engineers to assess and improve without physical presence on site. Hanson's making progress in many of these areas, and one example is robotics. And while the application that I'm about to show is not quarrying, it does demonstrate the willingness for our business to invest in this technology to assess its suitability in other areas of the business. The next video is of our Brisbane concrete laboratory and how robotics have been used to increase efficiency, safety and accuracy outcomes.
Along with ease of getting the job done for our customers and improved safety for our teams, a new concrete testing laboratory in Brisbane elevates the standard in high-performing integrated quality management. Until now, curing, crushing and cataloguing of concrete test cylinders has relied on a lot of manual handling. Much of this work is repetitive, and the equipment required to safely perform the task impacts on our cylinder capacity. In our brand new facility, we've automated the entire concrete compression testing regime by integrating precision robotics with our information management and delivery platforms. By eliminating bottlenecks, concrete testing is carried out on time, every time, and the results are available sooner. The strength of our new system starts on site, when the test samples are cast in new cylinders equipped with an electronic ID. This means that from the time the cylinders are delivered to the laboratory by a field tester, they will go through the entire process without ever being touched by a human hand. Upon receipt of the cylinders, the ID code is scanned and the sample is entered into our system. Once removed from the mould, product information and a barcode is printed directly on the sample. This gives traceability throughout the entire process. The automation system always knows which test is associated with which customer or internal testing sequence. We can be confident that at any point in the process, we know exactly where any test specimen is. The sample is then transferred to new lime water storage and curing tanks. These bespoke drawers integrate perfectly with the robotics, with the water quality in the tanks constantly monitored and adjusted to maintain optimal curing conditions. At the required time, the robotics retrieve the cylinder and transfer it to the crushing station. To prepare for crushing, the cylinder is cleaned and scanned once again. Once through the automatic grinder, the cylinder's weight and dimensions are recorded. It's then transferred to the compression testing machine. Cylinders from successful tests are discarded, while cylinders that haven't met quality expectations are retained for further investigation by qualified technical personnel. Upon completion of the test, the results are made readily available via our internal systems, but also to customers via My Hanson. So wherever you are, test results are always accurate and up to date. Our human attention will always be required, but by focusing those skills on the nuanced and variable aspects of our concrete testing operations while automating high-volume repetitive tasks, Hanson can achieve greater efficiency while maintaining our strict adherence to NATA testing guidelines. The traceability in our new system has transparency and confidence built in, and this industry-leading technology adds value to our business by freeing resources for other activities, and adds value for our customers through quality process assurances and better, more convenient access to test results. This scalable technology promises to reduce risk of injury, increase consistency in testing processes, and improve access to results.
Okay, so just in conclusion, the future of quarrying holds immense promise. Over the coming years, we can expect a transformative shift in the industry driven by automation, sustainability, and innovative materials. Quarrying will continue to play a crucial role in human development, enabling the construction of infrastructure that supports our growing population and enhances our quality of life. However, to harness the full potential of this future, we must remain committed to responsible practices, sustainable resource management, and the continuous development of our workforce. Overall, mechanical engineering will contribute to the quarry industry by leveraging technological advancements to enhance productivity, efficiency and sustainability, and through the application of innovative solutions, mechanical engineers will play a vital role in shaping the future of quarrying. Thank you.